In this video, I'm going to talk about the next form of data definition, which is called an interval. So this is really just an example, how to design data and data-driven templates problem. I've got the seatnum starter file open, and because this is a how to design data problem, I'm going to put the how to design data definitions recipe here off to the right. And over in my browser window, I've got the how to design data recipe page open. Back at the problem, so imagine that we're designing a program to manage ticket sales for a theater, and we want to represent the seat number in a row, and each row has 32 seats. So it's kind of a boring theater. That's what this comment here means, that it's a perfectly rectangular theater, and we need to represent a seat number. So if we think about that, a row looks kind of like this, and the seat number is going to be something like 1 or 2 or 3, all the way up to 32. Since these are seat numbers and not indexes in a string, let's use the normal kind of numbers that people like, where they start at 1 and go to 32. So the question is, that's the information. The information is numbers from 1 to 32 that are going to be seat numbers. How are we going to represent that? Well, if we go over to the How to Design Data webpage, and again, this is a webpage that you should read ahead of time. I'm going to be using it kind of in a mode where I already know how to use it. But I'm going to scroll down to this table that says when the form of the information to be represented is atomic. Well, this is atomic. Seat numbers are going to be something like 1 or 2, and that's atomic. But I'm going to keep reading because sometimes there's something more specific. And here it is when it's numbers within a certain range. And that's exactly what this case is. It's numbers like 1, 2, 3, all the way up to 32. So it's numbers within a certain range. And there's a kind of data definition for that called an interval. So here we go to intervals. And now an interval type comment looks something like this. There's a type name, and then we're going to say a kind of number, and then a notation for talking about the range. Let me jump back over here to Dr. Racket and do it, and I'll talk about that notation as I go. So let's see, we're going to say something like seat num is, and then these are numbers, integers, between 1 and 32. And what's going on with these square brackets is the square brackets mean inclusive. So this means integers starting at 1, including 1, going up to 32, including 32. Let me just show you some variations on this so you'll understand all of what we can say. For one thing, this could be natural, because natural numbers are integers that start at 0. So I could say natural here. Natural 1 to 32, integer 1 to 32, they're the same. But some other variations, for example, if I said something like number 132, well, that's going to be a lot more things, because numbers include real numbers like 1.3 and 1.4 and 1.5, and we don't have that with seat numbers. We really need naturals or integers here. If I said natural square bracket 1, comma, 32 round bracket, then that wouldn't include the 32, because a round bracket means up to but not including. So square means inclusive and round means non-inclusive. So there we go. There's our type comment. Now I've got to say interpret this. So what's the interpretation here? Well, let's see. These are seat numbers in a row, and I might know some more information about that. In particular, what I might know is that 1 and 32 are aisle seats. Okay? Or I might know something else about the theater. But anything that would help me understand exactly what the numbers 1, 32, and all the numbers in between mean is what I would put in the interpretation. And now let me make some examples. I'll say seat number 1, and I'll just call that 1. And seat number 2 might be 12. And seat number 3 might be 32. And the reason I'm going to do multiple examples in this case, sometimes it's nice to have examples that illustrate specific things. So this might be an aisle, and this is a middle, and this is an aisle, for example. You always want to have at least one example, and you should have other examples if they're illustrative. And again, as I said when we were doing the city name data definition, as data definitions become richer, examples will become more important and more useful. So we've got the type comment, the interpretation, and the examples. Now we have to do the template. So I'll start the template like this: define fun for seat num. And there's going to be some body there. And I'll also start the template process like this by saying template rules used. And now I'm set to do the template. I'll go back over here to the data definition page. I'll follow this link to the data-driven templates page. And now I've got to look down and find this form of data. And intervals are atomic non-distinct. So we're going to end up using the same template rule here that we used for city name, which is just open paren ... and the parameter name. So we go back here, we say open paren ... the parameter name, which is seat num, and here we say atomic non-distinct, and I always like to put after the colon here exactly what part of the type comment it was caused us to do that. You'll see starting in the next data definition we do, when data definitions get more complicated, why we're doing that. There we go. That data definition is complete. I'm going to run it now just to make sure everything's well formed. I didn't get any errors, so everything is well formed. I'll put a comment like that there, and we're good to go.